All right. So review for the quiz. You have a question here. Yes. Okay. This is an issue for many students. This is like conditional probability or dependent, depends on what they're asking. It says Jalen bought a book from a bookstore's clearance table. Use this table of values to find the following properties about his purchase. The book was 20% off. Well, 63 out of 200 books are 20% off. So the probability that he picked a book that was 20% off would just be 63 out of 200. I don't think that reduces. Okay. Was a hardback or 50% off means we have to count all the hardbacks plus all the 50% off books and make sure we don't double count any. Okay. So for that question, we'd have 75 hardbacks plus another 14 that are 50% off. So 75 plus 14, or you could have added 18, 22, 35, and 14. Should give you the same answer. And that's 89 over 200. Yes. Or means everybody wins if you got this or this. Okay, and means the only winners are hardback and 50% off. So that would be 35 out of 200, which does reduce, right? 7 out of 40. Okay. Now, does anybody remember how this works when we have a given? Yes. So given it was 30% off, means we are only talking about these. So it's going to be out of 88. What's the chance it was a paperback, given it's in that category, was 66 out of 88, which would reduce to 3/4, I believe. Okay, book was 30% off, given it was a hardback. Well, given it's a hardback, was only talking about this. So 30% off was 22 out of 75. I don't think that reduces. Yes, no, you're going to remember that? I hope so. Yes.
Okay.
If the probability of a successful football season is 0.6, what is the probability the next 3 seasons are all considered successful? We're supposed to assume that they are independent. So you would just do 0.6 to the third, which might be 0.216. Somebody double check me. Thanks. B says if the probability of a successful operation is 0.85, what is the probability that both of the next 2 operations are not successful? So not successful would be 1 minus 0.85 or 0.15. And then if you have 2 in a row, it would just be 0.15 times 0.15, which is 225.2, 0.0225, 0.225. That's what I thought, but that seemed really tiny. And you can change those to percents, but if you move the decimal over, you just need to put the percent symbol. What else? Yes, absolutely. Um, this is written on the quiz this way as well. Just to remind you, these are binomial probability questions, okay? So the probability that Boris gets a hit when at bat is 0.285. What is the approximate probability that he gets a hit exactly 2 of his next 8 at bats? When we first learned this, we did, well, how many different ways can he hit? How many, when the order doesn't matter, how many different ways can he get 2 out of 8? And then we want 2 to be successes, and we would want 6 to be failures, right? So success is 0.285. Failure is 1 minus 0.285, which would be 0.715. How did I do? 9, I think that's right. Okay. But there's another way to do this. It is a binomial probability, but we just want exactly one thing to happen, which is 2 hits. So we use PDF, and that's the only one we really ever did. We did CDF a couple times, but I wouldn't worry about CDF unless you're in stats. Then you might be more comfortable with it. But the prompts for binomial PDF are number of trials, probability of success, and number of successes. So we're going to put in 8.285 and 2. And that is under second vars. But you can't use normal. We're doing binomial here, which is A. Make sure you get the right one. Oh, that's interesting. Yeah, I was in something already, apparently. Oh, wrong. Okay, so out of 8 trials, was it 285, guys? And we want exactly 2 successes. So 0.304-ish. Not what you got? Yep. You can do that and you should get the same answer. Do you want me to show that, or just another way of doing it? Yep. Now number 9, on the other hand, there's multiple ways that this could happen. Probability that Tori gets to school on time is 0.85. What is the approximate probability that she gets to school on time at least 4 of the next 5 days? So she could be successful out of 5 days. She could be successful 4, or what? We want to count if she's there on time at least 4 days. So it would count if she made it 4 days, or that would be the same as making it 4 days. Yeah, she could make it all 5 days. So you could just add those 2 up. Because it works if she's there 4 or 5 days. .85, 4 days. Or 5 days. 0.835? No?
Yeah.
Okay. No, just 3 would probably be better though, but I would probably count it. What was it, 835? It's just that sometimes this little bit that you add on at the end is really small, and so, okay. You got those, guys? What else? Yep. Okay. So we're switching to the normal distribution section real quick. And in this section, says you can calculate z-score or go backwards and do the x. This one is asking us to go backwards. Okay. 16. So a 15 is just using this formula, guys. Put the numbers in and solve. 16 is asking specifically for empirical rule. So on your reference sheet, it says this is the mean. So you need to label this. For this question, the mean was 400. And then on the sheet, it says mean plus 1 standard deviation, 2 standard deviations, 3 standard deviations. Does everybody see what I'm talking about on the reference sheets? So this is an easy one. It says the standard deviation is 100. So this would just be 500, 600, 700. And going this way, it's 300, 200, 100. It says what percent of recruits scored higher than 300 or scored between a 300, scored higher between a 300 to 600. Oh, that doesn't make sense. But anyway, it's supposed to say between 300 and 600. And it says you're to shade this area. So this would be our shaded area. And then what percent is this? Well, using your chart that's on there, yes, this one you want to use the actual empirical rule. It says in here, 1 standard deviation each way is 68% total, right? Or 34 and 34. And then this next one is 13.5, I believe. Is that right? So if you add those together, you get 81.5%. Part B says out of 5,000 randomly selected recruits, how many would we expect to get a score between 300 and 600? So we want the actual number of recruits instead of the percent. We would just multiply, and I don't know what that is. You get 4075. Everybody get the difference between those two? This one wanted a percent, this one wanted an actual number of recruits that would represent. On normal distribution, this is another one that's just using the empirical formula. Do you want me to go through that again, or you got that? This again is an easy one because it's counting by standard deviations of what, 5? So it says the mean is 85. So then you'd have 90, 95, 100, and that's not percent, that's beats per minute. Going this way, you'd have 80, 75, and 70. Okay, and then it says about what percent is between 90, is more than 90 beats per minute. Okay, this is a little bit tricky because students forget that there's partially some out here beyond this. But the rule is this whole bottom half is 50%. Everybody get that? From here, either way is 50%. Okay? Don't add up all those little numbers. It's just the whole thing is 50% from there. So everything below 85 is 50%. But then there's also this 34% in here. So that's 84% would be below 90, but we want it above 90. Yes, the 100 minus 84 should be 16%. Now, if you add the little numbers on your chart, you miss like 0.5%, right? Is it 13.5 and 2.75? 2.35? Okay. But there's a little tiny chunk at the end you would miss, but it should be 16%. I don't think I made it that hard on the quiz. Okay. What percent is less than 75 beats? Well, again, if you were going everybody above this would be 50%. Then you'd have this 34% and this 13.5. And we want everybody below that. So 100 minus all of those, I think, is 81.5, isn't it? So we're left with 18.5. That's probably wrong. It should be 100 minus 13.5 minus 34 minus 50. What's left? Is it right? 18.5? Okay. Again, I don't think that's quite that tricky on the quiz. But I don't really want to leave normal distribution without talking about ones where you can't use the empirical rule, okay? In a normal distribution with a mean of 70 and a standard deviation of 3.8, okay, somebody help me do this fast. If it went up by 3.8, this would be 73.8 and another 77.6, 80.9. But going this way, minus 3.8 would be 60. Minus 3.8, 362.4 or 6 and something. Anyway, okay. This is what is the percent between 67 and 77.5? Are those numbers on our chart, guys? No. So we can't use this. We can't use, it's the ones in here, but we don't know that. So do you remember what we did instead? When we couldn't use empirical rule, because it doesn't fall right on any of those standard deviations, we did norm CDF. Yes, we didn't use norm PDF at all. Could have, but we didn't. Okay, and that one, does it say high and low, or is it low and high? It's low and then high, right? Low, high, mean, and standard deviation. Okay, so for this question, you're putting in 67, 77.5, 70, and 3.8. So it's the same place on the calculator. Second vars, but it's right near the top here. It's number 2 though, not number 1. If you do number 2, you don't get high and low, so you'll know something's wrong. And then what were they? Someone read them to me. So I got 0.761. This one says the scores of a standardized college entrance exam were found to be normally distributed with a mean of 85 and a standard deviation of 11. What percent scored above 75? So our low is 75, but how are we going to find the high if we want all the way up to forever? You could just put a really high number. It needs to be at least 4 standard deviations above the mean. I would just put like 9999. And then the mean was 85 and the standard deviation was 11. Somebody tell me what you get so I don't have to type that one. $75 and up. The mean was 85, standard deviation was 11. Yeah, 0.818 sounds great. All right. Everybody good on normal distribution? In theory, you could use the normal distributions to do 16 and 17, but you won't get the same answer as you will using empirical rule. And it specifically says in the question to use empirical rule. Yes. Yes, it has one section of parabolas and one section of hyperbolas. Yes, you get to use 2 reference sheets to borrow. The one on empirical rule and probability and the one on conics. I will have them both on your desk for you. In blue. Yep. Yeah. Let's just start with 12. Yep. Do you remember how to enter this in and then turn the plots on? I'm really nervous that some of you aren't going to remember this. Okay. I'm going to go to y equals and make sure I don't have anything entered in. And I'm actually going to go up here and turn the plot off just because that way I have to turn it on with all of you. I'm going to go stat, enter. You don't have a list two? Okay. We're really only worried about list 1. So I'm going to clear and enter to delete those numbers. Don't hit delete on the title or you have to re-enter the list name. All right. I'll try to type these. No. There's just 10 items in the list. Okay. It's not a frequency list. Okay. So the playing times of 10 movies were 102, 128, 160, 132, 104, 95, 109, 121, 108, and 200. Okay. To decide if this data is skewed, we have a couple options. We could look at the box and whisker plot, we could look at the histogram, or we could honestly decide if the mean and median have been dragged apart. What we did in class was we started with a histogram. So we did second, y equals, turn plot 1 on, and picked choice 3, the histogram. Make sure it says list 1. And then we did a zoom stat. Now, everybody may not get the same window, and I don't know that I would agree with their choice for their window, but it clearly is skewed, yes? Do you remember how we decide which way that's skewed? Which way is the tail dragged, okay? Yes, so the tail, let me see if I can draw in here. If I did, yeah, just kidding. All right, I can put it on the screen and then draw on it. It goes like this. So then you say the tail is dragged here to the right. So that would be right skewed. Which is C. Now, how can you decide? You can literally say, I made the histogram and it's skewed to the right. There's two other possibilities. The second one was you can look at the box and whisker plot. So you could go back in, and I'm just going to leave plot 1 on and change it to box and whisker, which is the 4th one over. You're definitely going to want the box and whisker plot because it asks about an outlier in this question later, okay? So go ahead and turn on the box and whisker plot, the one with outliers shown, which is the 4th one over, not the 5th one. Okay, then do a new zoom 9. And the reason it's skewed again is because if we were to drag this whisker all the way out to here, it would obviously have one whisker much, much longer, okay? But there is an outlier. So how would you decide for number 12? You could say the right whisker was significantly longer, or that the tail dragged to the right. And again, when you do that, you're really going all the way out to the outlier, okay? Are we good with that answer? Okay. Number 13 is all about the one variable stats. Do you remember how to find those? One variable stats? No. Anybody? This should be the easiest section, guys. Yeah, it's just stats, arrow to the right. One variable stats, okay? And we're not using a frequency list. So make sure you take out anything here or it'll give you an error. Or if you have numbers in there, it'll do a frequency list. And then which ones are we putting on here? The mean. Okay, did I already get that on there? Okay. The mean is the one with the bar over it, so it's 125.9. The does yours say population standard deviation or sample standard deviation? Right here for B, it does say population. And it has the right symbol, right? It has this little doohickey. That's what it says on the quiz. So that one's 30.5. All right, the 5-number summary, remember you have to scroll down further or look at the actual box plot for that. But So we have 95, 104, 115, 132, and 200. Is there an outlier? Yes, when we looked at the graph, there was an outlier, right? If you trace, it actually stopped the whisker at 160 and the outlier here is at 200. So yes, it does. Now, I could be real nice. What would you like to tell me? It's got a lot of room on the quiz, but the actual reason is because the value of 200 is more than 1.5 times the interquartile range past the Q3. But you don't have to tell me that. You could say, I graphed the box and whisker plot and it showed an outlier. Okay. I'm going to be a little more specific. Okay. The right whisker was going to be too long because the 200 was outlier. And when I say too long, it's more than 1.5 times the box. You don't have to say all that. I'm just trying to get you to remember why. Any questions? Is that whole section? Okay. I'm nervous about expected value. Anybody else nervous about expected value? We skipped those. 10 and 11? Or 10 A and B? Remember, it's net gain or loss times probability of that happening plus net gain or loss times probability until you've used up all the possibilities. Everybody forgets, though, that it's net gain or loss. If you buy the ticket, you have to take that away, okay? If you buy 500 tickets sold, I'm going to start with that. What's your chance of winning? There's only one winning, right? And the other 499 are losers. Okay. What are the losers losing? So you got to make sure it's a -2. What is the winner gaining? Yes, he had to buy a ticket, so he really only gained $748. Okay. Is it -50 cents? I don't remember. 748 divided by 500 minus 2 times 499 divided by 500, -0.5. So it means the average ticket holder will lose 50 cents. No one ticket holder can actually lose 50 cents. But if you bought all the tickets, you would lose an average of 50 cents per ticket. All right, another raffle one, since that's what's on the quiz. I gave you 2 examples. 100 tickets are sold for $5 each. There's 2 prizes, though. Okay, so there's 1 in 100 chance that you win the $1,000, and there's a 1 in 100 chance you win the 300, and then there's 98 tickets left over that are losers. Did I do that right? Okay. All the losing tickets, all those people lost $5 each, right? But what did the winners actually net?
1,000.
but they had to buy a ticket. I hope you're typing this so you know if you get this right. Oh, I got an interesting answer. Did anyone else get an interesting answer? I got 8 as well. I got positive 8. The only way it's positive is if it's a really good idea to buy a ticket. If I bought all of the tickets for this, I'd be $500 in the hole, right, guys? But then I'd automatically win $1,300 because I'd win both prizes. So I'd be $800 to the good. Divided by 100 tickets is $8 per ticket to the good. Yeah, I would definitely buy all the tickets if they told me they were only selling that many tickets, okay? You come out $800 ahead. That's why it's positive, because it's a dumb raffle. You remember discrete versus continuous, guys? We skipped this question, number 11. Which one is whole numbers? Yeah. Continuous is when it can be. So which of these has to be a discrete variable? Number of something. Yeah. Everything else could be measured as a decimal, right? The temperature, thickness of a bolt, height of a tomato plant, those can all be measured to like the nearest 10th or 100th or something, or 16th of an inch or whatever, 10th of a degree. All right. Did I skip anything else? Yeah. The very beginning ones? Did we get all those answers right or not? Number 5. This is just what's called counting principle. If she has 8 pair of pants that she can mix with 12 tops, and then she has 3 choices for shoes, right? So 288 maybe? Somebody check me totally on that one, but okay. So it's just the number of ways each separate category could happen. Does that make sense? Because an outfit had to have pants, top, and shoes. All right. How many ways can you choose a president, vice president, and treasurer from a class of 50? I would just do this. 50 times 49 times 48. But does anybody remember, is that a permutation or a combination question? No. It's a permutation because ABC counts different than BAC counts different than CAB. Okay. All of the ways that this could happen, every time it's going to count differently because, you know, whether Kayvon's president or vice president or secretary, those are 3 different things. So it would be out of 50 P3, or it's the same answer if you just did that. Does everybody remember where that is? It's under math. Arrow to the right, over to probability, and then it's choice 2. Anybody get that? 1176. Right, 5 cheerleaders will be chosen from a group of 15 students. How many different cheerleading squads can be formed? Okay, so you're just going to reach in and pick out 5 of them.
That's a common.
Yes, the order doesn't matter. And if you're not sure, you could do 15B5 and 15P5, and we want the smaller one, right? Because we don't want to count them all differently. But it should be C. It's like a committee, a team, anything like that is combination. When order doesn't matter. I know you feel like order would matter to you in your heart when you got picked, whether you got picked first or last, but it's not a different set of cheerleaders. What does this one come out? Okay, thank you. Okay, did I skip anything? Do you need the answers to these first few? Blue or green means there are 16 out of 24 winners, and you should reduce that. I'm just not going to bother. Probability of not drawing a blue on one try. So not blue means red and green. Those 12 are winners, which would reduce to 1/2. What is the probability that 3 red are chosen on 3 draws without replacement? So the first time there's 24, and then 23, and then 22. So we were doing red, so it would be 8, 7, 6. Anybody have that number down? Yeah, because that should reduce significantly. Did someone else get that? Red on 3 draws, red is 8 out of 24, and if you do replace it, the next time you go to draw, there's still 8 out of 24 and 8 out of 24, which is 1/3 times 1/3 times 1/3, which should be 1/27. Odds, remember, are winners to losers. So red jelly beans, 8. Not red, 8. Yes, no, 16, just kidding. So that can reduce to 1 to 2. And it can be written as a fraction. I just don't usually do it that way. Now did we cover everything? Anybody need to see a hyperbola or a parabola or have a homework question? Don't tell me.